What is the strangest thing humans have ever found on the moon? It wasn't aliens. It wasn't a hidden base. It was something that shouldn't have existed at all. As our new crewed lunar lander prepares for flight, this discovery has become more important than ever. It has been more than 50 years since Apollo astronauts last walked on the moon. No human has set foot there since. But we have sent dozens of probes. Some landed, some orbited, and some were deliberately crashed, just to see what might fly up from the impact. The moon is one of the most studied objects in the solar system. Yet, even after decades of research, it remains full of mysteries. How it stores heat. How it conducts electricity. Even the behavior of its soil. We still understand far too little. That's the universe for you. The deeper we look, the more questions surface. Before we had lunar soil, we imagined what we might find. But once we brought it home, we discovered chemical traces that shouldn't be there, and scientists have been scratching their heads ever since. You might imagine that a scientific discovery instantly changes everything. But real science moves slowly. Sometimes, everyone sees something but no one believes it. Our story begins in 1976. The Soviet Union launched Lunar 24, an uncrewed probe, on its final soil sampling mission. Nobody paid much attention at the time. It wasn't the first mission, and it wasn't dramatic. But quietly, it made history. It drilled nearly 2 meters beneath the lunar surface. It returned a narrow core of lunar soil, just 170 grams, about the weight of a baseball. Small, yes. But inside that slim tube of dust, something unusual appeared. A trace of water. About 0.1% of the sample contained water. And the deeper scientists looked, the more they found. It should have been groundbreaking. But instead, they dismissed it. They assumed the water came from Earth, contamination from the lander or the lab equipment. Textbooks insisted the moon was bone dry. This wasn't even the first time. Apollo samples had shown hints of hydrogen too, and researchers ignored those as well. So these clues that should have shaken the scientific world, sat quietly in old reports for decades. Until the early 2000s, when scientists asked themselves, did we overlook something important? But when we finally turned our attention back to the moon, it was ready to challenge us again. At the lunar poles, near the rims of giant craters, you will see something almost unnatural. Not because something is there, but because nothing is. No sunlight. No warmth. Only permanent darkness, untouched for billions of years. These regions are called permanently shadowed areas. Why? Because the moon tilts only about 1.5 degrees. Sunlight skims across the poles at a shallow angle. Deep craters never receive direct light. These regions are colder than Pluto, dropping below 240 degrees Celsius. Some of the coldest places in the entire solar system. Scientists began wondering in the 1990s, if comets or asteroids once delivered water to the moon, could some of that vapor have drifted into these frozen traps and stayed there forever? The idea caught fire. If true, the moon might be more than a barren rock. It could be a resource depot, even a future refueling station. The poles became the center of attention. But the challenge was enormous. Complicated terrain. No sunlight for solar panels. Extreme cold. And yet, if ice existed there, it would change everything. So probe after probe was launched. Their mission: find solid, undeniable evidence of lunar ice. The first scout was Clementine in 1994. It wasn't built to detect water, but it confirmed the existence of enormous shadowed craters. Then, in 1998, NASA launched Lunar Prospector, this time specifically hunting for water. It detected strong hydrogen signals at the poles, especially in the darkest craters. Some estimates suggested tens or even hundreds of millions of tons of ice. But hydrogen isn't proof of water. It could come from minerals or other compounds. Orbiters can't directly see buried ice. So once again, scientists had data, but no confirmation. The moon seemed to whisper, "There is treasure here, but I won't show it to you easily." So scientists turned to a more dramatic method. If the ice is hidden deep in a crater we can't see into, why not hit the crater and watch what flies out? In 1999, after its mission ended, Lunar Prospector was deliberately crashed into the moon. No water was detected. The angle may have been wrong, or the impact too weak. Uncertain results, again. A decade later, in 2009, NASA tried a bold new approach, LCROSS. Using the spent upper stage of its own rocket as a projectile, LCROSS smashed it into the South Pole's Cabeus crater. Moments later, the satellite flew through the ejector plume, analyzing it directly. This time, success. Real, measurable water vapor, not hints, not contamination. Water, plus methane, ammonia, and other compounds. It was the first undeniable evidence of water on the moon. Headlines, worldwide celebrated. Scientists toasted with champagne. But new questions emerged. How much water? Is it in solid blocks, mixed into soil? Too deep to reach? LCROSS had answered one question, but its own destruction meant no follow-up measurements. The lunar mystery remained unsolved. The next twist came from orbiters like NASA's Lunar Reconnaissance Orbiter and India's They began detecting faint water-related signals, not just in cold traps, but across sunlit areas of the moon. That made no sense. Daytime temperatures there exceed 100 degrees Celsius, hot enough to vaporize water instantly. Even stranger, the signal varied through the day, strong at night, weak or nearly gone at noon, then returning at dusk. It was as if the moon was sweating, evaporating in the heat, reclaiming moisture as it cooled. But the moon has no atmosphere, no pressure, no wind. How could water cycle in a vacuum? Scientists proposed theories. Micrometeorites delivering tiny amounts of water, or solar wind streams of charged hydrogen reacting with oxygen in lunar minerals to create water molecules on the surface. Whatever the source, the implication was profound. Water might be present everywhere on the moon, not just in dark craters. Thinly spread, but there, enough to matter. This possibility reshaped future mission planning. In 2023, India launched Chandrayaan-3, aiming directly at the South Pole, humanity's first landing attempt there. Scientists hoped its rover would confirm ice just below the surface. The rover scanned the soil with lasers and it found iron, calcium, sulfur, but no hydrogen. No hydrogen meant no water. Everyone was stunned. Had we been wrong all along? Or was the ice simply deeper than the rover's tiny tools could reach? Before more tests could be made, the long lunar night arrived. Temperatures plunged below 100 degrees Celsius. The lander and rover froze, never to wake again. They left behind a deeper mystery than before. But Chandrayaan-3 made one accidental breakthrough. Its temperature probe revealed something shocking. Surface soil can heat to over 60 degrees Celsius in sunlight. But just 8 centimeters below, temperatures drop to 10 degrees Celsius. A massive thermal gradient. This suggested the surface layer acts like insulation. A thick, dusty thermal blanket. Which means ice might be hiding safely just below this layer, untouched and invisible. Maybe the water isn't missing. Maybe our tools just don't reach deep enough. If that's true, the next lander won't need to fly farther or see more. It just needs a stronger drill. For decades, lunar water was mostly scientific curiosity, a way to study lunar history and chemical evolution. But now, it represents something much larger. A stepping stone to deep space. A foundation for future off-Earth habitats. Water that could be purified for drinking, used for cooling equipment, or split into hydrogen and oxygen, rocket fuel. If we can extract it, the moon becomes a refueling station. Launching from the moon, with only 1/6 Earth's gravity, becomes dramatically easier and cheaper. Water enables life support loops. It enables local agriculture in controlled environments. It enables long-duration missions. It enables exploration far beyond Earth. But one final problem remains. Despite all the missions, all the data, and all the optimism, we still don't have a clear, definitive map of lunar water. Orbiters see hydrogen, but landers find nothing. Impacts reveal vapor, but no visible ice sheets. Craters cold enough to preserve ice for billions of years still show no clear reflective patches. Everything remains ambiguous. Hints without answers. Signals without certainty. If we've misunderstood how the moon stores water, if the models need revision, or if the water is simply too thin, too deep, or too chemically bound to extract, we may not be ready for it yet. Maybe our tools, precise as they are, still fall short. Orbiters see everything from above, but touch nothing. Landers touch the ground, but cannot dig deep. It is science, with gloves on, always just 1 centimeter too shallow. And yet, humans do not give up. Where there is mystery, curiosity grows stronger. New missions are being built. More powerful drills. Smarter extraction systems. Next time, we won't just look. We will dig. We will reach beneath the moon's insulating skin and lift a handful of the future. Perhaps the moon will surprise us again. Perhaps it will reveal even deeper mysteries. But when we finally hold that solid, icy fragment in our hands, a new era, greater even than Apollo, will begin. And in that moment, our blue planet will no longer be just the cradle of our civilization, but the harbor from which we set sail toward the stars. If this journey sparked your curiosity, don't forget to like and subscribe to Interstellar Whispers. Your support gives me the motivation to create even more captivating videos about the universe, science, and the mysteries waiting beyond the stars. Turn on the notification bell so you never miss a new adventure. The next video might be the one that answers the question you've always wondered about. Thank you for traveling with Interstellar Whispers. See you in the next cosmic exploration.